Boolean literals. The constants true and false evaluate to 1 and 0 respectively. The constant names can be written in any letter case. So we're gonna check out these examples, and we need to log in with our credentials. I'm gonna use Windows PowerShell, so I need to type in MySQL-u, and my username is root, and then space -p. It's gonna prompt me for my password, so I'm gonna type in my password. And now what I'm gonna do is pretty much I need to type in select true in uppercase letters. So let's try it. It's gonna be like this. It's gonna be select, and it's gonna be uppercase letters true, comma space lowercase letters true, comma space uppercase letters is gonna be false, comma space, and it's gonna be false, but this time in lowercase letters. So it's gonna be like this, false. We ended up with a semicolon. We press enter, and here we're gonna have this table with 4 columns, true 1. So in uppercase letters true, in lowercase letter it give us again 1, false it give us 0 in uppercase letters, and also false it give us 0 in lowercase letters. So that's all that we have for the Boolean literals. So let's check out the next section. We have the null values. The null value means no data. Null can be written in any letter case. Be aware that the null value is different from values such as 0 for numeric types, or the empty string for string types. For more information, you can check out the section B3.4.3 problems with null values. For text file import or export operations performed with low data, or the select into out file, null is represented by the / uppercase letter N sequence. So you can check out the section 13.2.9 low data statement. For sorting with order by, null values sort before other values for ascending source, after other values for descending source. So that's all we have for null values. Let's check out the next section. And now we have 9.2 schema object names, and we're gonna see the identifier length limits, identifier qualifiers, identifier case sensitive, mapping of identifier to file names, and finally function name, parsing, and resolution. So let's check out this new chapter. Certain objects within MySQL, including database, table, index, column, alias, view, store, procedure, partition, table, space, resource group, and other object names are known as identifiers. The section describes the permissible syntax for identifiers in MySQL. Section 9.2.1 identifier length limit indicate the maximum length of each type of identifier. Section 9.2.3 identifier case sensitive describes which types of identifiers are case sensitive and under what conditions. An identifier may be quoted or unquoted. If an identifier contains special characters or is a reserved word, you must quote it whenever you refer to it. Exception: a reserved word that follows a period and a qualified name must be an identifier, so it need not be quoted. Reserved words are listed at section 9.3, keywords and reserved words. Internally, identifiers are converted to and are stored as Unicode UTF-8. The permissible Unicode characters in identifiers are those in the basic multilingual plane. So we have the B and P. Supplementary characters are not permitted. Identifier DAS may contain these characters. So here we have the permitted characters in unquoted identifier. So in the ASCII, we have in these brackets, we have from 0 to 9. We also have from the letters, the lowercase letter from A to Z, and the uppercase letters from A to Z, and the $, underscore. Basic Latin letters, we have the digits from 0 to 9, we have the $, and the underscore. So extended, we have the U, the uppercase letter U, the +0080, U +FFF. Permitted characters in quoted identifiers include the full Unicode basic multilingual plane, so the BMP, except uppercase letter U +0000. So ASCII, we have the U +0001 and the U +007F. Extended, we have the U +0080, U +FFF. ASCII null, we have the U +0000, the quadruple 0. and supplementary characters. So we have the U plus 1 quadruple 0 and higher are not permitted in quoted or unquoted identifiers. Identifiers may begin with a digit, but unless quoted, may not consist solely of digits. Database, table, and columns names cannot end with space characters. Beginning with MySQL 8.0.32, use of the $sign as the first character and an unquoted name as a database, table, view, column, store program, or alias is deprecated and produces a warning. This includes such names used with qualifiers, so you can check out this section, the 9.2.2 Identifier Qualifiers. The $sign can still be used as the leading character of such of an identifier when it is quoting according to the rules given later in the section. The identifier quote character is the backtick, so we are gonna use the select from all columns, and inside of the backticks we're gonna type in the word select, but it's gonna be in lowercase letters. Outside of that we're gonna have the close where, and outside of that we're gonna have again in backticks the word select, but it's gonna be in lowercase letters. That ID that has to be less than 100, and we can check out. So I already log in with my credentials, and let's check it out. So it's gonna be select, and let me see, it's gonna be select from all columns. So it's gonna be select from all columns, and we're gonna use in the backticks, and it's gonna be in lowercase letters select, and it's gonna be the close where. Okay, so and then in backticks we're gonna have in select, and we're gonna type in that ID, and it has to be greater than 100, like that, and then to semicolon at the end. And table comment queries doesn't exist. Okay, so we need to create a table in this, let me see, show databases, like this, and we're gonna use comment. Okay, it's gonna be comment queries, like that. So okay, so we are using the comment queries database, so we're gonna create some tables. But first, if the NC underscore quotes SQL mode is enabled, it is also permissible to quote identifiers within double quotation marks. So here we're gonna create this table. We're gonna type in create table, like that, and the table, so we're gonna type in double quotes, and inside of the double quotes is gonna be named test. But let me see, before that I want to show tables, so I want to show tables, so like this, and we have animals, child, parent, tab, T1 and T. Okay, so now we can just type in create table, like that, and then inside double quotes we're gonna have in test. Outside of the double quotes we're gonna open parentheses, we're gonna have the column and lowercase letters, and then we're gonna have the integer in uppercase letters. So we ended up with a semicolon, and okay, it's gonna throw us an error. Okay, so you have an error in your SQL syntax, so check out the manual corresponding to your SQL server. Okay, syntax use near test and line 1. Okay, so what we are gonna do right now is we are gonna pretty much use this word set, so it's gonna be set, and we're gonna set the SQL underscore mode equal sign single quotes. So we open single quotes, we ended up this statement with a semicolon, and inside of the single quotes we're gonna type in NC underscore, and we're gonna type in quotes, like this. So we type in enter, and now it give us set SQL underscore mode. Oh my bad, I type in NC outside of the single quotes. Okay, so we press enter, and then query 0 rows affected, so that's fine. And now we can pretty much create table and double quotes, and we can name it test. Okay, so since this is inside of the double quotes, outside of the double quotes we're gonna have this parentheses, we're gonna have the column name integer, or just cal and then a space int, ended up with a semicolon, and now query so 0 rows affected. So we have that. The NC underscore quote, the NC underscore quotes mode causes the server to interpret double hyphen quoted strings as identifiers. Consequently, when this mode is enabled, string literals must be enclosed within single quotation marks. They cannot be enclosed within double quotation marks. The server SQL mode is controlled as described in section 5.1.11 server SQL modes. Identifier quote characters can be included within an identifier if you quote the identifier if the character to be included within the identifier is the same as that used to quote the identifier itself. Then you need to double the character. The following statement creates a table name A, so it's going to be lowercase letter A, and then we have in backticks B, lowercase letter B, that contains a column name C, double quote, just a single double quote D. So let's try it. We're gonna type in create in uppercase letters, so it's gonna be create a table, and we can pretty much show tables like that to see how many tables we have. And as you can see here, we created this table named test inside of the double quotes, so we have it right here. So now we have 7 tables in our common query database. So let's create another table. Let me see, it's gonna be create table, and we're gonna have not single quotes, it's gonna be backticks, and it's gonna be inside of the backticks is gonna be lowercase letter A. Okay, and then let me see. Okay, so next is we're gonna open again another backticks, and this time is gonna be inside of the backticks is gonna be lowercase letter B space, and inside of the parentheses we're gonna have backticks lowercase letter C, one single double quote letter lowercase letter D backtick, and outside of that we're gonna have the int or just int, and then we ended up with a semicolon and query. Okay, 0 rows affected, so we have that. And the select list of a query, a quoted column alias can be specified using identifier or string quoting character. So select 1 as 1, 2 as 2, so we have the now. Okay, so we can try it out, this example. We're gonna have in select, okay, it's gonna be select number 1 as inside backticks and let the word 1 comma, so we're gonna separate it by a comma the number 2 as, and now it's gonna be inside single quotes the letter or the word 2. We ended up this statement with a semicolon, and here we have this table. So in this column we have 1 and word, so this is the number, the word 2, and the number 2. Elsewhere, okay, elsewhere in the statement, quoted reference to the alias must use identifier quoting, or the reference is treated as a string literal. It is recommended that you do not use the names that begin with me, uppercase letter M and lowercase letter e, or uppercase letter M, lowercase letter e, uppercase letter M, where uppercase letters M and N are integers. For example, avoid using 1 and then lowercase letter e as an identifier, because an expression such as 1 lowercase letter e plus 3 is ambiguous. Depending on the context, it might be interpreted as the expression 1e space the plus sign space 3, or as the number 1e plus 3. Be careful when using the MD5 open close parentheses to produce table names, because it can produce names in illegal or ambiguous formats such as those just described. It is also recommended that you do not use column names that begin with inside of the exclamation mark hidden, to ensure that new names do not collide with names used by existing hidden columns for functional indexes. A user variable cannot be used directly in an SQL statement as an identifier or as a part of an identifier, you can check out the section 9.4 user-defined variables for more information and examples of workarounds. Special characters and database and table names are encoded in the corresponding file. System names as described in section 9.2.4, mapping of integers to file names. So that's all. Well, this is the second part for the schema object names, and now we're gonna move into the next section. And now we have the identifier length limits. The following table describes the maximum length for each type of identifier. So in this table we have the identifier type and then the maximum length, so in characters. So the database, so we have 64 maximum length in character, includes NDB cluster 8.0.18 and later. We have the table 64 includes NDB cluster, the same, and the column 64, index 64, constraint 64, store program 64, view 64, table space 64, server 64, log file group 64, alias 256, see exception, following table, compound statement label 16, user defined variable 64, and resource group 64. Aliases for column names and create view statements. So if you want to know more about it, you can check out the create view statements. So you have a bunch of examples here. You can check out this link. Are checked against the maximum column length of 64 characters, not the maximum alias length of 256 characters. For constraint definitions that include no constraint name, the server internally generates a name derived from the associated table name. For example, internally generated foreign keys and check constraint names consist of the table name plus underscore ibfk underscore or underscore chk underscore and a number. If the table name is close to the length limit for constraint names, the additional characters required for the constraint name may cause that name to exceed the limit, resulting in an error. Identifiers are stored using Unicode UTF-8. This applies to identifiers and table definitions and to identifiers stored in the grant tables in the MySQL database. The sizes of the identifier string columns in the grant tables are measured in characters. You can use multiply characters without reducing the number of characters permitted for values stored in these columns. So prior to the NDB 8.0.18, NDB cluster imposed a maximum length of 63 characters for names of databases and tables. As of NDB 8.0.18, the limitation is removed. So section 23.2.7.11, previous NDB cluster issue resolving the NDB cluster, you can check out more about it. Values such as username and host names and MySQL account names are string rather than identifiers. For information about the maximum length of such values as stored in grant tables, you can check out the grant table scope columns properties. And that's all we have for the section 9.2.1 identifier length limits. So let's check out the next section. Let's see what we have here. So we have in the 9.2.2 identifier qualifiers. So we have some examples. Object names may be unqualified or qualified. An unqualified name is permitted in contexts where interpretation of the name is ambiguous. A qualified name includes at least one qualifier to clarify the interpretive context by overriding a default context or providing missing context. For example, this statement creates a table using the unqualified name T1. So let's check out. So let's see what it gives us. Let me see. It's going to be create table T1. I think I already have the table T1. It has to be in lowercase letters, so we already have it here. But let's see what happens. And inside of the parentheses, we're gonna have the letter I, and then it's gonna be the integer. So ended up with semicolon. And table 1 already exists. So okay, so we already have the table 1. Because the T1 includes no qualifier to specify a database, the statement creates the table in the default database. If there is no default database, an error occurs. This statement creates a table using the qualified name db1.t that t1. So let's see, let's try something. So show, okay, let's show tables like this, and let's just drop table, let's just drop table t1 like this. Okay, so now again show tables, and we don't have the table t1, so let's create it again. Okay, so it's gonna be create table. Okay, create table t1, and we're gonna use inside of the parentheses lowercase letter I space integer. So okay, query, okay, shows, okay, 0 rows affected, and let's see, now show tables, and now we have the table t1, so that's fine. Now okay, so because t1 includes no qualifier to specify a database, the statement creates the table in the default database. If there is no default database, an error occurs. This statement creates a table using the qualified name db1.t1. So create table d1. So let's try it out. Let's try this one. So it's gonna be create table db1 like this, that t1 space open close parentheses I, and it's gonna be integer. So let's see what happened. Okay, unknown database b1. Let me see, create table db1.t1. okay, so we have that. Because db1.t1 includes a database qualifier db1, the statement creates t1 and the database name db1 regardless of the default database. The qualifier must be specified if there is no default database. The qualifier may be specified if there is a default database, to specify a database different from the default, or to make a database explicit if the default is the same as the one specified. Qualifiers have these characteristics. An unqualified name consists of a single identifier. A qualified name consists of multiple identifiers. The components of a multiple part name must be separated by the period characters. The initial parts of a multiple part name act as qualifiers that affect the context within which to interpret the final identifier. The qualifier character is a separate token and need not be contiguous with the associated identifier. For example, we have the tb1 underscore name that column underscore name, and then we have the tb1 underscore name that column underscore name are equivalent. If any components of a multi-part name requiring quoting individually rather than quoting them as a whole. For example, we have the right and backticks my hyphen table, that backticks my column, not backticks my hyphen table, that my hyphen column. A reserved word that follows a period and a qualified name must be an identifier, so in that context if need not be quoted. The permitted qualifiers for object names depend on the object type. A database name is fully qualified and takes no qualifiers. So let's create this database, and this time it's not going to be a table but it's going to be a database. Let me see if I have it. So databases. Okay, so show databases. So these are my databases. Now I'm gonna create a new one, so it's gonna be create database, and the name is gonna be db1. So database 1 like this. So it work, and now okay, so now we have it here, database db1. Okay, a table view or a store program name may be given in a database name qualifier. Examples of unqualified and qualified names and create a statement. So we have the create table, and then this name would be my table, and then 3 dots, semicolon at the end to end up this statement. Create view, my view, create procedure, my procedure or my prod, create function, my function, create event, my event, create table, and then would be my db.myTable, create view. So it would be my db.myView, create procedure is gonna be my db.myProcedure, create function is gonna be my db.myFunction, create event, my db.myEvent. So a trigger is associated with a table, so any qualifier applies to the table name. Create trigger here, the name would be my trigger, and then just ellipses. These three dots are named as ellipses. On my table, then ellipses again, ended up with a semicolon. Create trigger, my trigger, ellipses on my db that my table, and then ellipses, and then semicolon. A column name may be given multiple qualifiers to indicate context and statements that reference it, as shown in the following table. So in this column reference, we have the column underscore name, that the meaning is the column underscore name from whichever table used, and the statement contains a column of that name. We have the tbl underscore name, that column underscore name, column underscore name from the table db1 underscore name of the default database. We have the database, or the db underscore name, that dbl underscore name, that call underscore name, the column call underscore name from the table db1 underscore name of the database db underscore name. And in other words, a column name may be given a table name qualifier, which itself may be given a database name qualifier. Examples of unqualified and qualified columns reference and select statements. So we can check out select c1 from my table, then where c2 is greater than the number 100. Select my table that c1 from my table, where my table that c2 is greater than 100. And then we will have the select my db that my table that c1 from my db that my table, where my db that my table that c2 is greater than 100. Okay, so you need not specify a qualifier for an object reference in a statement unless the unqualified reference is ambiguous. Suppose that the column c1 occurs only in table t1, so c2 only in t2, and c and t1 and t2. An unqualified reference to c, lowercase letter c, is ambiguous in a statement that refers to both tables and must be qualified as t1.c or t2.c to indicate which table you mean. So it will be something like this: select c1 comma c2 comma t1.c from t1, and then inner join t2 where t2.c is greater than 100. Similarly, to retrieve from a table t and database db1 and from table t and database db2 and the same statement, you must qualify the table references. For referencing to columns in those tables, qualifiers are required only for column names that appear in both tables. Suppose that column c1 occurs only in table db1.t, c2 only in db2.t, and c in both db1.t and db2.t. In this case, c is ambiguous and must be qualified by c1, and c2 need not be. So here the example would be select c1, c2, and db1.t that c from db1.t, inner join db2.t where db2.t.c is greater than 100. Table aliases enable qualified column references to be written more simply. Select c1, c2, t1.c from db1.t as t1, inner join db2.t as t2, where t2.c is greater than 100. So that's all that we have for the identifier qualifiers.